Okay, let me first share my screen. Okay, let's start with questions. We are in module number 3. So do you have any questions about, let's see over here. Module 3 is going to end tomorrow. Any questions regarding module 3?
No questions.
All right. Okay. Now, before we start, I do actually have to ask one question, and you can answer it any way you want. I mean, it's not going to affect anything. Um, so right now the class timing is, you already know that I'm making that trip to for a conference and all of that stuff.
Right.
6:30 is like, this is the best time for you. 5:30 is going to be a problem, or 4:30 is going to be a problem for you. You're busy at that time. How does that work?
No. So you want to do it, and our times might be different. So for
Hmm.
me, right now it's 7:30. So would you
Okay.
want to do? Are you saying you want to do 6:30 instead, or 5:30 instead? So I think
Well,
you're
my time is central, so right now it's 6:30. So I was thinking, what if we do it only for a couple of, only for like, you know, 2 weeks or whatever. What
Mhm.
if we do it at 4:30? I don't know what time. 4:30 Central. So
So
what if
4:30
4:30?
Central. That'd be 5:30 for me, I believe.
Okay, and that will be okay.
Yeah, that's fine.
Okay, let me actually type it out. So 4:30 CST. For you, it will be 5:30. For me, it will be 10:30, I think. 10:30 London time, whatever. London, UK. Yeah, that will be fine. 10:30 to 11:30 should be okay.
Yeah, that's much better for you than 1:30 or
Yeah,
12:30, whatever it was going to be.
yeah, it was like 12:30. Um, and yeah, and when the time is changing to 6:30, I'll let you know. But right now, for this week, the time is still 6:30. And I'll let you know. Like, I'll let you know probably on Sunday. I'll send you an email that the Monday class will be at 4:30. I guess you're in Eastern, right? Sorry,
Hmm.
you're
Yeah,
in
I'm Eastern.
Eastern, so your time is 5:30 Eastern. Your time will be 5:30 Eastern. Okay, all right. Well, thanks. Yeah, that will be a little bit better for me, I guess. Yeah. All right. All right, let's see. Okay, so today I wanted to talk about, I think it's already in your, this is actually in module 4, but module 3, I think we covered pretty much. Let me actually double check it, but I think we covered most of the stuff. Let's go to assignments. Okay. Visualizing the data and all that stuff. So we already covered a lot of visualization. Module 3 labs. And module 4 is linear regression. Where is the decision tree? I'm looking at that. Well, anyway, it doesn't really have the decision tree, but it is an important thing. So we'll cover the decision tree. And in the module 4, some of the stuff we have already done, which is good. Linear regression, we have already done. Logistic regression, we have already done that. So k nearest neighbors, we already done that. Couple of different things we have to still do, and like cross validation. This is module 4, by the way. So, and regression tree, I think maybe this is what they're calling decision tree. But decision tree is, no matter what you do, it's still in there in the course, in the Xi books. So if you look at the module 4, section 7.22, this is decision tree, which is again going to come in module 4, but this is what we're going to cover today. The decision tree, as you can see, it's more of like a choices. Like based on the choice that you select or based on the option, you will go a certain route. And once you reach the leaf is the final. So this one is the leaf. This is kind of like the final node that you reach. You can see there are 3 leaves, so meaning 3 different outputs or 3 different decisions, or not decisions, I would say, but 3 different routes or paths it can take, which can lead to 2 different outputs: accept a job offer or reject a job offer. So if we start from the beginning, does the applicant have another job offer? Okay, if the answer is yes, then is the current job offer better than the other job offer? Then yes, then okay, accept the current job offer. So it's pretty simple scenario where if does the applicant have another job offer? No, then accept the current job offer. And then if does it have another job offer? Yes, but it's not a good offer, then reject the offer. So these kind of scenarios we deal with every single day. Like, okay, if I work for Google and some people work for, Facebook, then what is the relationship between, like, how many of us can be making more than $100,000? Is it based on our degree? Is it based on if you're working on Google versus Facebook versus Apple? So how does that work? So whenever we have situations where we have multiple choices and we have to draw kind of like a flow chart or a tree, as you can see, we can use decision tree algorithm. Now, this is a pretty simple one because it's kind of like, does the applicant have a job offer? Yes and no, and then there's one other option. But this can become really complicated. So this one is a little bit more complicated. And this is like when you are trying to display, well, not display, but when you're trying to give some advertisement to the user. So this is kind of like those kind of decision trees you can create. But the main problem you encounter with these decision trees is, I'm going to take an example, actually. It's a really good channel on YouTube. It's called Code Basics, and this guy really gives really good examples, like over here with the Google example. Yeah, so I'll share the link. This guy has a lot of good stuff right there. All right. So in this example, he's talking about that if somebody gives you this data in an Excel spreadsheet, and where there is a company name, there is job, whether you're a sales executive, degree, whether you have bachelor's or master's, and then the one that I was talking about, whether you're making more than $100,000 or not. 0 means you're not making 100,000. 1 means you are making 100,000. So looking at this data, it's kind of hard to find out that what factors are affecting the employee making more than $100,000. So if we go forward, you can see that he tries to divide. Let's actually see how it's dividing. He tries to divide or create this layout based on the company. So if the root is the company, and then there are 3 different things coming out, Google, Facebook, and ABC Pharma, then you can see over here in Google, there are a couple of people, like 1, 2, 3 people who are making $100,000. In Facebook, you have pretty much all of them are making 100,000. And then in ABC Pharma, you have like, one of them is making 100,000 and other people are not making 100,000. So basically, he talks about that it's a good idea to break these things out. I mean, this is one way to break them, but if you go forward, he shows you that you can also break them into different ways. Like you can even go drill down into business manager or computer programmer, sales executive, and so on, and even more, right? I mean, this can become super complicated, like how you're actually breaking them away or breaking them down. So this is called the decision tree. And based on the decision tree, you are going to find out, classify whether the person is making $100,000 or not, based on all of these company. Google, okay, yes. If a person works on Google, gonna go here. If a person is a computer programmer, oh yes. As a bachelor, yes. Oh, you're not gonna make $100,000. So according to our machine learning model and training. But if a person works on Facebook, oh, well, no matter what your degree is, no matter what your occupation, what your title is, you're always gonna make 100,000. And then for ABC Pharma, it's like you are ABC, you work for ABC Pharma, you're a business manager, you have masters, only then you will make 100,000. So these kind of scenarios where your decision is based on previous decisions and a tree-like structure is born, these kind of decisions can be, you know, evaluated using a decision tree algorithm. And one of the things he talks about is that once we are dividing these things, you can see that how they're dividing it, company, Google, business manager. But once you're dividing these things, it's always a good idea to divide it in such a way or based on such attributes or features where you have clear winner. You can see all green, clear winner, that this is, it has low randomness, or I think it's called low entropy, which means that you can see all of them are green. It's not mixed together. If you divide it by degree, how many people are making 100,000 versus not 100,000, you can see that some of them are making 100,000, the green ones, but some of them are not. And in the masters too, some of them are making 100,000, some of them are not. So this is not really good for dividing based on a degree, is not really good for machine learning algorithm because it has more randomness. There is too much randomness going on over here. A couple of them are red, a couple of them are green, but this one is pretty good actually. All of them for the Facebook are green, and most of them for ABC Pharma are red. So this has a little bit of a low randomness, and that's why it will be a good idea to use a company to make the decision tree. But obviously, when you're working with something really complicated, you don't really have only one attribute. You have like hundreds of attributes, and then it will be very hard for humans to even start drawing these things. So that's why we give this task to the computer, and the computer and the decision tree algorithm can be used to make it happen. So let's go ahead and look at a more complicated example where we may have like a lot more features, and using the decision tree, we are going to find out if a person is going to accept a job or not accept a job. So let me actually share with you the data set. Let's see, it's on GitHub. Let's see. So decision tree right there, you can see applicant job acceptance. I can share this link with you, but this is only for, I guess, this particular course. And if you scroll, you'll find applicant job acceptance, which is simply a data set. And if you look at this data set, we'll find something interesting. All right. All right, let's see. So looking at this data set, we have applicant ID, we have experience level, education level, years of experience, salary expectation, relocation desire, no or yes, accepted offer. So accepted offer is the target. That's what we are trying to find out based on these features, right? And we can use decision tree algorithm to find out. Now, the first question is, looking at this data set, can we clean it up? Well, are there any columns, any features that have no impact, or at least what we think that will have no impact on the accepted offer? What do you think?
I guess this is dependent, but maybe the relocation and the
Like
well,
maybe
no,
the
no,
application
app
ID.
ID
Yep.
definitely,
Yeah.
definitely app ID.
Yeah. So applicant ID there, I mean, you can say like some sort of employee, or not even employee, applicant ID, but randomly assigned. That has no impact on accepted offer or not. Experience level, yes. Entry level, I think they will accept the offer more than the senior level, I guess, depending on the offer, I guess. Education level, years of experience, salary, expectation, relocation. Yeah. So all of them do look like that they will play a role in making this accepted offer true or false, or yes or no. So let's go ahead and work with that. So I'm going to go ahead, and you can download the data set if you want. I think you can just click on draw and just copy this data set. All right. So I'm going to go ahead and create a new notebook. And select something. And you will see that since we're using scikit-learn, the procedure is pretty much simple. So all the things you have learned are going to play into it. But since decision tree is also part of one of the scikit-learn algorithms, you're going to see that it's going to be obviously fit and predict. Those are the two functions you need to remember. So first, I'm going to go ahead and import pandas as PD. And then let's go ahead and load pd dot read CSV. I think our file name that I called it, when I saved it, I called it job applicant acceptance.csv. Let's see, I don't think they have any save. That's fine. Okay. Let's go ahead and see what it has. Okay, so I mean the same thing that we were discussing. It's not like something different. Applicant ID, experience level. So the first thing we need to do is applicant ID doesn't really have anything to do with anything. So we can just remove that. So df dot drop a particular column, which is applicant ID. And this will be on the axis of columns. df dot head again. Okay, so we have now removed the applicant ID column because that's not really needed. What do you think what do you think, what else should we do with these things?
And I'm guessing encode them.
Yeah, okay. Yeah, so we can encode, this one, we can encode this one, and we can encode probably this one. Accepted offer, I don't think we need to encode it. I mean, no and yes is fine. I don't think that we need to encode this part because that's not really, I mean, it's just two what we have to know. It's not like some other complicated text. So that's the classification label, so that should be okay. So in order to encode, we will need to import sklearn dot pre-processing import label encoder. Oops, pre-processing. Okay, we don't need that. So from. And then we can create an instance of the label encoder. Label. And you'll see that all the things that you have learned, they're all going to come into play. And then in the end, we'll just, instead of using logistic regression or KNN, we'll just start using decision tree. So the first thing we will encode in this case is LE dot fit and transform. And we are transforming experience level. I'll just copy it from here probably. And this is going to return us something. And that's something we can use to create a new column in our data frame. So now if I say data frame.head, we will actually have a brand new column, experience level. And I mean, you can call this anything you want, but I'm just calling it N as a number. Using the same approach, we can do for the education level and also for the relocation desire. And if I run this and try to do df.head, now we have these multiple columns that we just added, which have numbers in there, which is good because machine learning works way better with numbers than with these text-based things. So now we can go ahead and we don't really need these columns, these three, so we can start dropping them. So df.drop, and we are going to drop experience level. We are going to drop education level and relocation desire. And axis will be columns. And this is going to return us the new data frame. So we're just going to assign it to the old one. And now our data frame is looking actually pretty good. It has, most of them have numbers columns, except the accepted offer, but that's, I think, okay. It's just yes and no. From here, we can create X and Y because we will need X and Y to train. So X will be df dot dropping the column, this one. This will be our independent variable. So we're going to just drop one column.
Wait, I'm sorry, I might have missed it. Why
Hmm?
did we drop relocation?
Let's see. This one?
Yeah.
Yeah, we dropped relocation because we added a column for the relocation, this one.
Oh,
Mm.
sorry. I
Yeah,
didn't even see. I'm sorry. I didn't
yeah.
see that.
So we added that column. Now I'm wondering that, yeah, I think the only reason we dropped relocation is because it's a string column, and for the training, we just wanted to convert 010101, much, I guess, much better. But yeah, so that's why we dropped pretty much all the string uh, columns except for the accepted offer, which is our target column. That's the one that we wanted to find out. So that's the one that we didn't drop. And this is now our new data set, but we need to create X, meaning on the X-axis, all the independent variables. And that will be everything but the accepted offer column. So we can say df.drop accepted offer. Again, access columns. So, and Y will be the thing that we're trying to find out. So this will be df accepted offer. All right. So if I print out Y, you can see it does contain some stuff. No, yes, no, yes. And if I print out X, well, it contains all the stuff. All right. So what do you think will be our next step?
To, I guess, go ahead and train it.
Right? So in order to train, it's always a good idea to create those train test split. So let's go ahead and use that. And that will really be handy when you have like hundreds and thousands of records. We only have like few. sklearn.model selection and import train test split. So that's one of the important functions. So we have already done most of the stuff. In the train test split function, we can pass in the X, we can pass in the Y. Test size is 0.2, which means only 20% will be the test size and 80% will be the training. And now it is split at least. Now we can actually train it. Now, in order to train, we have to create an algorithm. I mean, we have to use some sort of a algorithm or a model. So just like with other stuff, sklearn contains everything. sklearn.tree, import decision tree classifier. There's also decision tree regressor, which is different from decision tree classifier. Regressor is the one that's going to find the price of a house, find the price of a car. But classifier is going to classify between known labels. And that's what we are trying to do. We have a label yes and no that we want to classify. And mostly with decision trees, you are going to be using classification rather than regression, although it can be used, but mostly you'll be using a classifier. So we imported that. I can create a new, that's a tree instance by saying decision tree classifier. And just like creating a logistic regression, linear regression, now this tree will have the fit function where we can pass in xtrain and ytrain. And training is already done, super fast. We don't really have that much data. And now let's go ahead and first let's check out the score. And when you're checking the score, you have to provide some data that it hasn't seen so we can calculate the correct score. So X test and Y test. Well, score is kind of crazy because like 100%. Probably our data is too small or, it's, well, I guess easy for the decision tree to find out, but it's 100% accurate or 100% confidence. And now we can try to predict, and we can predict it using just passing the X test, which is a data frame that contains a lot of different rows. And this is what it returns. Yes, no, yes, 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 no. So if we print out X test, so 12 years of experience. Okay, so all of this basically. So 12 years of experience. Oh, what is this then? I think this is just a number. Well, these numbers are not really. I don't know what this 8 is over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Something salary expectation. If maybe these are just index numbers that if putting out. Yeah, I think these are all randoms because it's randomized, right? So these are just
Right.
these are just we don't have to worry about. That's nothing. All right. So 8 years of experience, salary expectation 80,000, experience level 1, education level 4, relocation desire yes, that person will accept an offer. Okay. But a person who has 1 year of experience, salary expectation, accepted offer is no. So based on the data, this is the result it's giving us. All right, so this is kind of like using decision tree to solve a problem that is decision based, like something depends on other thing, just like in our graph. Where is it? This one. Current location, if it's supermarket, your age, if it's over 40, if age is below 40, and things like that. So eventually when you reach a decision of yes and no, it will be based on other decision that you took previously. All right. So this is decision tree. Any questions regarding this?
No, that seems straightforward.
Right.
Actually, this seems really similar to logistic regression.
Hmm.
So I understand the main difference is that it's, I guess, doing a decision tree.
Hmm.
But in this specific scenario, what would be the difference between doing logistic and decision tree?
Yeah, I mean, both are, well, logistic regression, but this is more of a classification. Classification means we already know the labels that eventually we are going to apply, which is either going to be yes or no. So classification will always be putting or stamping a label on your answer or your target. Is it yes? Is it no? But logistic regression, not logic, I think you said, yeah, logistic regression is basically trying to find uh, the price. So that will be the logistic regression. Oh, sorry, logistic. I think you're calling logistic classification, right? I think that's what you're mentioning. So let's see.
Like, because we have linear and then we have logistic, right?
Yeah, yeah.
So logistic was, yeah, logistic is like, yeah,
Okay,
yeah.
okay. Yeah, I like to always call
So
it like,
sorry.
no, I always like to call it like classification because that's what they call it in iOS also, like classification. But yes, okay. So you're talking about the classification, which is the logistic regression, which is logistic classification. Yeah, both of them are similar. Um, and they will produce similar result. I mean, they will classify yes and no kind of thing. When to use when is obviously a very difficult question to answer. I think when your things have a more hierarchy, more relationship, and more dependencies on each other rather than the final result alone, then maybe the decision tree might be a better solution in those points. But when you're trying to say, well, I have 100,000 whatever, like the square feet house and 4 bedrooms, and this one, is it inside the city and outside the city? If those variables, those features are not correlated with each other and they are just kind of like independent in nature, but they do contribute to the final result, maybe in those cases, the logistic regression or logistic regression will be a much better approach. But in the end, you will have to try both the approaches and see which one is better suited for your problem. Yeah. And we will, in the future, we will tackle or we will cover also that how do you even, like, like linear regression, logistic regression, KNN, how do you choose the algorithm? Because there's so many, how do you even find out that which one to choose? So we're going to cover that in the future also. But yeah, both of them will produce the same result. In this case, which one will be faster, which one will be slower? That's hard to tell without doing the actual score. Yeah. All right. All right. Any other questions?
No, that was pretty straightforward for me.
All right. Let's see that if we can actually implement logistic regression right here. From sklearn, let's see, import How do we import logistic regression? What was it? Model something? Let's actually double check it. We can probably test it out and see the score also. Let's see. Import logistic regression. I think it was like linear model or something. Yeah. So sklearn.linear _ model import logistic regression. Not like that, just this. And logistic regression, LR. Logistic regression. There we go. I think we already have the data set xtrain and ytrain and xtest and ytest. So this means that logistic regression dot fit x train, let's train it, y train. And let's check out the score first before we do anything. Score with x test and y test. Ooh, see that? And that's how you will decide that, oops, maybe the decision tree is much better.
That makes sense.
It's
Okay.
66%, and that was 100%. So in this scenario, decision tree is better. Now, not on all scenario, but in this particular scenario. Right? All right. So let's see over here. I do have, I don't know why I closed this. Okay, let me just open it up again. Oh, it's right here. All right, so let's go back. Let's go over here. And this. All right, so I do have some decision tree activities for you. Churn rate. Using the data set below, use the data set below to find whether a customer has churn or not. Churn means that whether the customer is continuing their service or not. And let's check out the data set. Okay, pretty similar stuff. You have customer ID, you have contract, internet service, monthly charges, total charges, and churn. Churn 1 means that the customer has decided, I'm going to disconnect the service, and churn 0 means I'm going to keep the service. And this is real stuff. I mean, I'm sure that AT&T, Comcast, pretty much all of these subscription membership-based websites, they will have some sort of algorithm, way complicated. We only have like what, 1, 2, 3, 4, 5 features. One of them is useless, so 4 features. And they will be looking at these features and they will be like, oh, these 4 people who are similar features, they have the DSL or fiber, whatever, they are churning like, super fast, like they're just disconnecting their service or they're not continuing their plan. So what can we do to fix that? So this is churn is a real problem, and how to manage it is a real issue. Like, so let me give you this in the chat, and let me.
Can you also send me the one line that you use to import the
Yeah,
the
I'm
decision
gonna.
tree?
Yeah, I'm going to try to give you all of this. Let's see, what is this called? Decision tree class work. And probably it should be somewhere over here. That's one. And then decision tree class work. Okay, so that Python Yeah, so that should be there. I think you can double click it. It will open it in Visual Studio Code. Sometime you can do that. Although I don't really, I'm sure you can run it from Visual Studio Code, but I just like to use this much better. Okay. All right, so I'm gonna go ahead and open out the break.